Back in the 1990s, the software world was staring at a huge mystery. A brand new operating system called Linux was taking off. But it wasn't built by some big corporation. Nope, it was being built by a totally scattered global community of volunteers. Eric S. Raymond's famous essay, The Cathedral and the Bazaar, tried to solve the puzzle of how this was even possible, and in doing so, it pretty much changed everything.
I mean, this was the central question, right? For decades, everybody just assumed that really important software had to be built by these small, super disciplined teams working in total secret. And yet, here comes Linux, this sprawling, messy, chaotic project, just getting better and better at a speed nobody could believe. It just didn't make any sense.
So, to explain what was going on, Raymond came up with this really powerful metaphor, that there are two fundamentally different ways of building things.
Now, what's really fascinating here is that Raymond himself was a veteran of the old school. He totally believed in the traditional way of doing things, this world of individual geniuses, working away in private, only showing off their creation when they thought it was absolutely perfect.
He gave these two competing ideas perfect names, the Cathedral and the Bazaar. One represents quiet, centralized, top-down planning. The other, well, it's a noisy, decentralized, chaotic marketplace of ideas.
So let's start with the model that pretty much ran the software world for decades, the Cathedral.
In the Cathedral model, everything is under tight control. You have a small group of architects who design the whole thing way in advance. The source code is treated like a state secret, and it only gets released to the public on a strict schedule, once it's all polished and supposedly complete. In this world, bugs are seen as these deep, nasty flaws that only the high priest of code can possibly find and fix.
And you can probably guess the problem with this method. After months, sometimes even years of working in secret, this perfect piece of software would finally be released, and it was never perfect. There were always bugs, which of course led to a whole lot of disappointment.
And then along came Linux, which championed a completely different model, the bustling Bazaar. Now, if you were a cathedral builder, the Linux method looked like pure, unadulterated anarchy. I mean, they were releasing new versions of their code all the time, sometimes every single day, and they made everything public right from the start. It honestly looked like a recipe for total disaster.
But here's the thing. This apparent chaos wasn't random at all. It was driven by this revolutionary principle that just completely flipped the script on how you build reliable software.
And this is it. This is the whole idea in a nutshell. Raymond called it Linus's Law, named after the creator of Linux, Linus Torvalds. Given enough eyeballs, all bugs are shallow.
So what does that really mean? Well, think about it. In the Bazaar, a bug that might take one expert weeks to find becomes glaringly obvious in just minutes when you have thousands of people all looking at the same code. The problem isn't that the bug is deep. It's just a matter of getting the right pair of eyes on it. And in a big enough crowd, that happens really, really fast.
Raymond was so taken by this theory that he decided, you know what, I've got to put this to the test myself.
So he took over the small utility program and decided he was going to run it as a deliberate experiment in the Bazaar style. He released his work constantly, even with all the flaws. He talked with his users every single day. And, this is the most important part, he started to see their feedback not as a complaint, but as a gift.
So what happened? Well, he didn't just find a few people to test his code. He grew a community of almost 300 active code developers. These people weren't just customers, they were his collaborators, finding problems and suggesting solutions way faster than he ever could have on his own. The theory didn't just work, it absolutely thrived.
But this all raises an even deeper question. Okay, the method works, but why? What actually motivates thousands of highly skilled people to pour all their time and energy into a project for free?
Yeah, this is the economic puzzle, isn't it? In an industry that's driven by multi-million-dollar contracts, why would some of the most talented people in the field just give away their time and their best work?
Raymond's big answer was that the open source community doesn't operate in an economy of scarcity. It operates in one of abundance. He called it a gift culture. See, when you can copy and distribute software for basically zero cost, hoarding it has no value. Your status comes not from what you own, but from what you contribute.
The rewards in this culture aren't about money, they're about earning the respect of your peers, the thrill of tackling a really fascinating problem, and the deep satisfaction of building something useful. It's about the pure, creative joy of the craft itself.
In this powerful social engine, it wasn't just some niche thing. It was an idea so potent that it was about to break out of the hacker world and right into the heart of the tech industry. Just look at this timeline. It's wild.
Just months after Raymond published his essay online, Netscape, a huge Wall Street darling at the time, made this absolutely shocking announcement. They were giving away the source code to their main product, their browser. And their chief technology officer explicitly credited the Cathedral and the Bazaar as a fundamental inspiration for their decision.
That was the moment the idea escaped the lab. A Fortune 500 company just bet its entire future on the Bazaar model, and in doing so, it kicked off a revolution that would completely rewrite the rules for the entire software industry. So the principles of radical transparency, decentralized collaboration, and a culture of sharing, they turned out to be a much better way to build complex systems. It utterly transformed the world of software. So the only question left for us is, where else could this model change the world?